Hi, my name is Arija Thubaiti. Our research project is entitled Detecting Routing Attacks in Industrial Internet of Things. Sectish architecture was proposed to bring together the high reliability provided by the link layer along with the internet protocols. So it just glue the two together. So Sectish adapted the routing protocol Ripple since it provided with a loop-free structure and it has a very low communication overhead comparing the rest of the routing protocols in the wireless sensor networks. So our Ripple builds the routing topology or a destination-oriented directed acyclic graph or DODAG where devices select the best path toward the root of the topology according to a set of metrics and constraints named the objective function. Accordingly, each device will have a numeric representation or numeric value represent its location in the DODAG or in the routing topology in regard to the root. We refer to that value as the rank. The rank decreases when we move up in the DODAG and increases in the opposite direction. Devices in the Ripple communicate with each other through four control messages. The first one, DODAG information object or DIO, where the device shares its routing information. DODAG, the second control message is the DODAG information solicitation or DIS, where a new device want to join the routing topology has to send it to let its neighbor that it needs the up-to-date DIO. The third control message is the destination advertisement object or DAO, where the device sends its destination information to the root, and the root has to reply with a DAO acknowledgement and just to let the device that it successfully received its DAO. Unfortunately, the Ripple is not prone against internal attacks. The devices are kind of weak against, they can be easily compromised and reprogrammed to behave maliciously. In our research project, we focused on four attacks. First, we are going to discuss the decreased rank, where the compromised device sends a DIO with a better rank value than its original. So the neighbors will think that it has better place toward the root. The second attack is the rank attack based on the objective function, where the compromised device, it's similar to the decreased rank, but the compromised device here sent a DIO with a better path or better routing metric toward the root. Increased rank in the third attack is the increased rank, where the compromised device creates a loop where it rather than selecting a better parent, it selects its child. In the last attack, we have worst parent selection attack. It's against the objective function. So the compromised device select the worst path toward the root rather than selecting the best path toward the root. And thus, we first introduced our centralized specification-based IDS named ARM, where the detection fully performed by the root, and the rest of the Ripple devices report their routing information to the root. As you can see here, the finite state machine of ARM. ARM can detect, unfortunately, ARM can detect only two attacks, decreased rank and rank attack objective function. Thus, we proposed our fully distributed specification based named Force, where each device is considered to be a monitoring device and has to analyze each received control message from its neighbors. Both our IDSs have been evaluated through extensive simulation scenarios, and they both are not requiring of the devices to perform high computation, nor to have storage space or drain any power. That that's why they're lightweight and they are suitable for Secdish network.